So let's take a moment to talk about electrical force. Electrical force is one of the three main non-contact forces that we deal with. The first non-contact force that you guys see in your everyday life a lot is actually gravity. So if you pick up your pencil and you just let go of it, the reason it falls down, as we know, is because of the force of gravity. And we can see that there's absolutely nothing touching that pencil. It's just naturally attracted to the ground. And the reason is because gravity is a non-contact force. The second one that you guys tend to deal with is electrical forces. And this one can actually be seen in your everyday life. It's probably was shown to you when you were a child. If you actually blow up a balloon and you rub it against a sweater or you rub it against your hair, you can get that balloon to stick to a wall a lot of the times. And the reason you can get it to stick to a wall is because you've given it a charge. So now you have a charged object touching the wall, and as it touches that wall, it's going to have an electrical force between those two objects, causing them to attract each other. But that is actually a contact force. What you could do is if you do that same thing, but instead of go ahead and touching it to the wall, just put it a little bit away from the wall, and you'll find out that when you release that balloon, it'll travel and touch the wall itself all on its own. It's not because some draft is coming in, it's because the charges from the balloon are attracted to the charges in the wall, and that'll make them stick and come together, just like when you drop your pencil, it attracts itself to the ground. So let's go ahead and take a look. After many, many years, scientists have discovered that the electrical force is equal to Q1 times Q2, times Q2 all over R squared. So K is actually a constant that scientists have discovered. K is 9 approximately, 9 times 10 to the 9th, and the units on that are newtons times meters squared over c squared, where c stands for coulombs. That is the charge. That's how we actually measure charges. So we've got a constant here, we've got the two charges, and then we've got the distance between those. R stands for the distance between the two objects. So in order to have an electrical force, you've got to have an object and then a second object so that they can attract or repel each other. If you're looking pretty closely, you might actually see that this equation looks very, very similar to another one that we've studied. So F sub g in this case is equal to g m1 m2 all over r squared. So notice those similarities. You've got a constant, you've got something, some property of an object, property of an object, property of a second object, property of a second object, all divided by the distance between them squared. And if you remember, this is actually the equation to calculate the gravitational attraction between any two objects, where g in this case is 6.67 times 10 to the negative 11th, and the units on that are meters cubed per kilogram times second squared. So very, very similar, and on the next page we're actually going to do a problem comparing these two. So let's go ahead and without further ado jump right into it. So go ahead and take a moment to pause and read this question. Alright, I'm going to write a bit of relevant information in order to solve part A. So the first thing we need to know is about the proton. A proton has a charge. Every single proton in the whole wide world has a charge of positive 1.6 times 10 to the negative 19 coulombs. So a very, very small charge on a proton. It turns out this is actually the smallest charge you can ever have on an object, and all objects will be some multiple of this. That's because charge is what's called quantized, where you can either have an excess of either a proton or electrons on an object to create that charge. But you can never just have, let's say, 1.5 times 10 to the negative 19th. That actually doesn't exist. So a little fun fact for you. An electron has the exact same charge, but it turns out that charge is negative. So if you have one electron and one proton, you actually have zero charge cumulatively. But they can still be attracted to each other. And that's our job right now, is to figure out what is that charge. So I'm going to go ahead and write out my equation. Q1, Q2 all over r squared. And we just do a little bit of substitute and solve. So K, as we saw in the previous slide, is 9 times 10 to the 9th. These are taking the absolute value, so I'm just going to go ahead and write both of them as positive. 1.6 times 10 to the negative 19. And if I was feeling a little bit lazy, I could just write squared. Oop, that's a 6. I could just write squared over here and neglect the second one because it is the same thing, but I'm going to go ahead and leave it just so that I remember that I've done it properly. So 0.02. So what I've done here is I've actually plugged in that radius. The distance between them was 2 centimeters, but I need to put it in my standard index units, standard units to 0.02 meters, and that's why I plugged in 0.02 meters in there. I'll make sure I get that SI unit in there. So plugging all this into a calculator, be very, very careful because you do have a lot of scientific notation in there. You want to make sure that you don't accidentally forget something or you mess up how you plug it into your calculator. But when I did it, I ended up with an answer of 5.76 times 10 to the negative 25th. And then the units on this, since it's a force, is newtons. Which turns out to be a very, very small force. It's completely unnoticeable. If someone were to come over and push on me with that force, I would have no idea that they're even touching me. So it's extremely small, the attraction between a proton and electron. So let's go ahead and figure out the gravitational force between them. So how are they attracting each other? And in order to do this, we do need to know the mass of a proton. The mass of a proton can be found in a lot of different sources, but the source that I found approximated it to 1.67 times 10 to the negative 27 kilograms. Next, we need to know the mass of an electron, which is actually much, much smaller, which is 9.11 times 10 to the negative 31 kilograms. So a big difference between these, but both of them are very, very small. The radius is going to be the exact same, 0.02. So let's go ahead and write out that equation, F sub g this time, m2 all over r squared. So the gravitational force between them is going to be 6.67 times 10 to the negative 11. All of this is multiplied by the mass of a proton, 1.67 times 10 to the negative 27 times 9.11 times 10 to the negative 31. Again, all over 0.02 squared. Be very, very careful plugging in all this stuff into your calculator as well because it is very easy to make a mistake. And once you plug it all in, you'll find out you've got 2.537 approximately times 10 to the negative 64 newtons. So this is extremely small. When you compare the electrical force versus the gravitational force, the electrical force is much, 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 much larger. So yes, it is a very small force, but it's still a lot more powerful than the gravitational force between things. So that's just something to keep in mind as you're working through, is that the electrical force is going to give you very, very small numbers, but it doesn't take a lot of force to move these very, very small objects. So keep that in mind, and also keep in mind that the electrical force is going to affect these objects a lot more than any sort of gravitational force between them. It's a very common misconception that people have, is that objects that small end up getting attracted through gravitation versus electricity. But those electrical fields can create a lot more powerful forces than gravitational fields at those small levels. You know, I just realized that I did not fully answer this question. So that's always one thing to make sure that you go back and read, because I did calculate the magnitude, but I never calculated the direction. So real quickly, let's go ahead and figure that out. The very easy and obvious one is going to be gravitational force. Gravitational force is always going to be pulling those objects towards each other. So the gravitational force between them is toward the other object. So towards each other. And then let's go ahead and figure out the electrical attraction. So here we need to remember that opposites attract. The proton and the electron, they do have different charges on them, so this will also be toward each other. So that's a very important thing. Make sure you do go back and read those directions because that is something that I forgot to do, and it's very, very easy to happen to you as well.